Hello calculus students and general seekers of truth. In this video we will look at an example with a particle moving along a straight line, and this time in this function we are given a position function. And so this is important to consider because in other cases we might be given an acceleration function or a velocity function or a distance function even for that matter. So with that in mind, we can proceed. We want to know what is the velocity at time equals 3. And whenever you hear velocity, it's talking about instantaneous velocity. If this was average velocity, the problem would specify it. So just to refresh your memory, remember that velocity is equal to the derivative of position. So what we're looking for here, another way to say this, is v of 3 or s prime of 3. Either way, s prime of 3. So either way is perfectly fine to describe this problem. They're equivalent expression. So let's take the derivative of s of t. So this gives us 3t squared minus 18t plus 17. We want to know the velocity at exactly 3 seconds, so we're going to substitute 3 in here. This is 3 times 3 squared minus 3 times, not 3, minus 18 times 3 plus 17. Working out all the arithmetic, we have 27 minus 54 plus 17. 27 and 50 and 17 gives you 44 minus 54, so that gives you negative 10. And the units are also important here. The position is measured in meters and time is measured in seconds. This is velocity is a rate, change in position over change in time, so our units here are meters per second. So negative 10 meters per second. So this also means that the particle is moving to the left at this point in time when t is equal to 3 seconds. Alright, so continuing on, we want to know when is the particle moving to the left. And remember, moving to the left in the context of this problem is whenever the velocity function is negative. Okay? Or another way to say it is that the derivative of the position function is negative. So we already know that the velocity was equal to 3t squared plus 17, what was it, plus 18t, excuse me, minus 18t plus 17. And in order to find where it's negative, we need to first figure out where it's equal to 0. So 3t squared minus 18t plus 17 is equal to 0. So solve this your favorite way. You can solve it by graphing or the quadratic formula. That is not really the essence of this lesson. I've solved it already, and I know that t will equal 1.174. and t will equal to 4.826. So now let us consider the sign chart for v of t. We know that v of t is equal to 0 when you have 1.174 and 4.826 rather. Well, this being a quadratic with the leading term positive, so I know that it's going to look something like this, some graph that looks kind of like this, so that I know that the graph is going to be negative here, positive here, and positive here. So if I didn't know this was a quadratic, I'd have to test it, but just using our knowledge of the shape of functions, we can deduce that quite quickly. So you can see here that the velocity is negative between 1.174 and 4.826. So our final answer is when t is equal or is between 4.826 and 1.174. Now, for those of you who are sticklers regarding physics and math, we can have a lot of fun arguing about whether this is strictly less than t or less than or equal to. For the AP exam, it doesn't really matter which one you put, but technically correct, it's less than or equal to. For a different lesson on that, for a clear explanation on that, we have to work on some higher level math in order to really settle this debate. That is beyond the scope of this video here. So speaking of this video here, I'm going to end the video as is and start a new one that picks up on this problem where we left off. Thank you for watching and have a wonderful day.